Hello, am I audible?
Yes,
Yes, ma'am.
Yes,
ma'am.
ma'am.
It's a revision
Yes, ma'am.
session.
Yes, ma'am.
My screen is visible?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Ma'am, your voice is cracking.
My voice is breaking.
No,
Yes,
ma'am.
ma'am, your voice is breaking.
No.
No, it's fine.
No, it's not.
Most of the person says no, so I think it's not.
That's fine.
You can check. Now I am audible clearly, right?
Yes,
Yes,
ma'am,
ma'am.
now it's
This
fine.
is,
ma'am.
Yes, ma'am. It's fine, ma'am.
Ma'am, this is the revision session or
Okay. So
ma'am,
we will start within 2 minutes. Yes, someone wants to say something.
like this is the revision session, right?
You are not audible clearly.
Am I
Say it
audible,
louder.
ma'am?
It is a revision session.
Ma'am,
Aimed
it's
with
a
the revision session.
Yeah,
week
this
1
is
and
the
2
revision
only.
session for week 1 and 2. We will go through some of the concepts, and we'll try to solve some of the practice questions which will help you in your quizzes, and yeah, you will get some
Okay, ma'am.
benefits.
Got it, ma'am.
Yeah.
Ma'am, actually, I have a doubt regarding the quiz one exam.
Yeah, you can
so
send in the
So my question is, ma'am, is there going to be any negative marking in the quiz one exam?
no, there won't be any negative marking.
So there is no negative marking?
Yeah, there is no negative marking in the quiz.
Okay, thank you, ma'am. Hello, ma'am.
Yes.
Ma'am, I have also a doubt regarding the qualify exam. Ma'am, actually in the portal, it is written that we have to score greater than or equal to 40% in the qualified exam.
Yeah.
Ma'am, so we have to score 40% in the 4 subjects separately or in the overall marks?
So I don't idea about that, but I
40
think you have to
ma'am.
score
Overall
Yes.
50, overall 50%. Yeah, but per subject 40.
Exactly 40%. Each subject we have to score 40%.
It depends
Yeah,
on it depends.
Average
Ma'am,
should
it
be
depends
greater
on
than 50%.
category, ma'am. It
Average should
depends
be
on the
greater than
category.
right.
Yeah, it depends on
So
the
I think
category, ma'am.
overall you have to score 40.
Yes.
Means in combination of the 4 subjects, that is CT, Maths, Stats, and English, we have to score 40% overall.
No, in
No,
each
overall
Wait, and
50%.
last sum
Overall
also.
also and in
Overall 50% and
Overall
40% for each
50% and
subject.
Overall 50%, individual 40%.
This is for general candidate, and there is a separate candidate for there is separate mark for OBC and SC/ST. 35% for OBC and 30% for SC/ST.
Okay, ma'am. Thank you.
Oh, sir, can you please tell me what is the timing for? Actually, I am a JEE level student, so I will give giving quiz one. So can you please tell me what is the timings for maths and statistics paper? As it is, I know the exams will be between 2 to 6 p.m. But what is the actual timings for the maths and statistics papers?
Actually, I don't have any idea about that. I think you can switch between, it's up to you which paper you start first. Maybe that's how it works.
I'm sorry, I couldn't understand what you just said.
See, actually, I don't have that much idea about it, that what's the particular timing, but I think you will get overall 4 hours for 4 subjects. So I think you can start any subject from your
No,
choice.
I will be giving only 2 papers because I have chosen 2 papers. I must add that I have directly qualified for the foundation course.
You'll get 2 hours for 2
All
subjects.
right. All right. So and then I think I can leave, right?
Yeah, I mean, if you want.
Fine.
Ma'am, can we switch the subject during the exam time?
I don't know. I don't know about these technical
can
things. You can
switch
ask these
subjects during the
technical
exam
things
time.
in next session.
We
The
can
sir will
I
take.
think these questions, yeah, I think these
Ma'am,
questions
can we
should be addressed
continue
to the
with our
coordinator.
IQs?
Could we start the session?
Yeah. Okay. So we'll drop these all technical things. We'll discuss it at the end of the session.
And I have
We'll start the
request.
session.
I have request you kindly mute everyone. Also close the chat.
Sorry,
Because
you are
else,
not audible.
can you mute everyone and also close the chat because we won't be able to take
yeah.
the session till that. We can
Because
have this
otherwise
audio.
we'll.
Yes,
run
ma'am.
away.
Mute
Also,
everyone.
please do disable the.
Don't mute yourself. This is someone share the WhatsApp chat. Fine. So in this session, I want to discuss some of the topics from week 1 and 2. Mainly the topic related to the relations, definition of function, domain, and the Venn diagram, union, intersection, all those concepts. Okay. So let me start with the basic definition of relation. My voice is clear to everyone, right?
Yes, ma'am.
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am. Your
Yeah.
voice is clear.
Sorry, what?
Yes,
Like
ma'am.
Yuri,
Your voice is clear.
yeah, look like Yuri.
all reply in the chat box only rather than
Yeah,
unmuting us.
please reply in the chat box. I'll mute you all, but
I mean, can you make a full mute?
yeah, now you can't mute yourself. You can ask me in the chat box. I'm looking at chat box. Let's get started. So we'll start with the basic definition of relation. I'll just quickly go through it. So what do we mean by relation? So suppose we have a set A, then a relation is nothing. So R is said to be a relation. R is said to be a relation on A if R is a subset of A cross A. So by A cross A, we mean that A cross A, we mean that yeah, you have to study up to 4 weeks. This session will contain this session will based on week 1 and 2, and the next session, next revision session, will be based on week 3 and 4. So we plan 2 revision sessions for our course. So by a Cartesian product A cross A, we mean that this type of set that it will contain a pair A comma A dash type, where A and A dash both are the elements of set A. Now, in place of A, we could take 2 sets also. That let's say A and B are 2 sets. And R is a subset of A cross B. Then R is a relation on A and B, which will take the elements of A and B both. And by again, A cross B is nothing but a set which contains a pair A comma B, where A is an element of A and B is an element of B. Now on relation, we have certain definitions, certain properties, namely reflexivity, symmetricity, transitivity, and all. So we will discuss each of the property here. So let me once go through it quickly, and then we will solve our first question. So if we have a relation R, then this relation is said to be, first thing is reflexive. If A comma A belongs to R for all A in A, that means every element should relate it to itself. That means the sphere A comma A should belongs to R for all A belongs to it. Then we say that the relation is reflexive. The second property is symmetricity. Symmetric. So we say a relation is symmetric if A comma B belongs to R, implies B comma A also belongs to R. So the hypothesis is A comma B should belongs to R. That means if A is related to B, then B should relate it to A. That's what we know as symmetricity. What do you mean by QS? Okay. So now the third property is transitivity. So by transitivity, hypothesis is that if A, B are related and BC are related, then AC should be related. So if a relation satisfies this condition, we say that it's a transitivity. I mean, the relation is transitive. Okay. So these 3 are the basic properties of a relation. So a relation could have reflexivity, symmetricity, transitivity, either of them, and 3 of them also at the same time. Okay. So now we have a simple question here based on a relation concept. So is this question is visible to everyone? Yes. So I'll give you 5 minutes to solve this question. So just try it out. and we will discuss it after that. And if someone applied for 2 subjects, they will get 2 hours for qualifier exam. Okay, so solve this and we'll discuss it at 8:25. Yes, set X is not visible now. Now is it visible? Sure. Yeah. So by reflexivity, okay. Reflexivity is used only when the relation is based on the, okay, so here this option is not considered, okay, this right. So, but it's not. Because reflexivity needs to be defined only when the relation it's depend on only one set, A cross. Then only we can check reflexivity. Because a relation is said to be reflexive if A comma A belongs to R. And for A comma A belongs to R, we need a relation defined on A cross A only. Here relation R1 and R2 both are defined on X cross. So that means reflexivity we don't need to consider. Sorry. So R2 is all A comma B belongs to X cross Y in such a way that A plus B mod 10 is equals to 0. So you know modular arithmetic, right? What do we mean by A plus B mod 10 is equals to 0? So in general, if X mod 10 is equals to 0 means that 10 divides X. That means 10 should divide X, then it says that X mod 10 is equals to 0. Yeah, the remainder is 0. So that means the X should divide, 10 should divide X. In a positive integer, we don't have to consider 0. 0 is neither a positive nor negative. So we don't consider positive in 0. 0 to be a positive integer. If you want to write it, if you want to consider 0, then I should write it here non-negative integer in place of positive. Okay. So by positive, we mean strictly greater than 0. Not 0. Okay. All set of odd positive integers. Odd positive integers. Wait a minute. Odd positive integers. Yeah. So by mod is something which represent the remainder if we divide them. So here you just have to understand what does this mean. X mod 10 is equals to 0. So if they written X mod 10 is equals to 0, so that means 10 should divide X. That means the remainder is a remainder should be equals to 0 when 10 divides X. So here they say is R1 is symmetric, is R2 is symmetric, is R1 is transitive. This is R2, is R2 is transitive and R1 is transitive. Ultimately, you have to say which of these R1 is symmetric or transitive, R2 is symmetric or transitive. I haven't got any of the answers. So if you get the answer, please answer in the chat box. After that, we'll discuss. Don't worry, we can go up to 11. So we have plenty time to discuss. There's no such thing unsymmetric. Okay, so let's discuss this question. See, so here they say X is what? So X is a set of odd positive integers. So that means since it is positive, so that means we have to consider 0, 1, 1, 2, 3, 4, 5, and so on. And secondly, it's an odd set. So that means X is nothing but 1, 3, 5, 7, 9, 11, and so on. These type of elements are the members of S. Okay. And the second set is y. So y is what? The set of positive integer less than 30 and divisible by 4. So by set of positive integer, we means again the integer of from starting from 1, 2, 3, 4, and so on. And we have to say that they are divisible by 4. So the least positive integer which is divisible by 4 is 4 itself. So that means 4, 8, 12, 16, and all multiples of 4 up to 30. So we know that 20, 24, 28, right? These are the elements we have to take up to 28. So this is the set 1. Now the relation R1 is defined to be that all A comma B belongs to X cross Y. So A comma B belongs to X cross Y means A belongs to X and B belongs to Y, in such a way that A is a factor of B. So factor of B means B can be written as A multiple of something, right? So that's the meaning of factor. By A is a factor of B means B can be written as A multiplied by something. So that means A should divide B. You can understand from like this, that if A divides B, then we say that A is a factor of B, right? So R1 we have to take all such pair in where A should divide, right? So you know that 1 divides every integer. So that means 1 comma 4, 1 comma 8, and so on up to 1 comma 28 are the elements of R1. Now let's come to 3. Now you know that 3 divides 3 cannot divide any of the if 3 divides some 4 multiple of something, because what we need that which are divisible by 4. So that means if 3 divides 4 multiple of something, there should be a 3. So that means 3 divides only 12, and 3 divides only, now 3 divides 36. So that means 3 can divide only 12. So that means 3 comma 12 will be element of. Now let's go to 5. Now we know that 5, if 5 divides 4 into something, there should be a 5. So that means 5 divides 20. So 5 comma 20 will be there only. So we are done with this. Now again, if 7 divides 4, so there should be something is there. So that means 7 comma 28 is also an element of R. So 7 comma 28, right? Similarly, if 9 divides 4 into something, 9 should be there. So that means 36. But 36 is not an element of Y. So that's why we cannot consider. Similarly, if 11 divide 4, so there should be a something, but again 11 should be there, so it's 44. Again 44 is not an element of Y, so it won't be there. So that means these are the only elements belongs to R1. Okay. Right. So this is your R1. So R1 is clear to everyone. Is there any doubt or any missing element in R1 you find? Just reply no if there's any. No. Someone raise hand. Divya, you can unmute yourself now.
Ma'am, you should include 3, 24.
Sorry, what?
3, 24 should be included.
3, 24. 3 divides 4 into something. Yeah, there could be 6. So yeah, correct. 3, 20. Thank you. Any other thing? Yeah, you can check by this thing that if 3 divides 4 multiple of something, that means 3 should present here. Now we can again take 2 because if 3 will get cancelled out, right? So that means 24 should present. Similar thing can we do with 5? So if 5 should be present there, so 20. So if I take 2 here, so 40 will become. So that means we cannot do this thing with 20, with 5. Correct. So these are the elements we get for R1. Now similarly, I'll try to find out all the elements which belongs to R2, right? But R2 is a little bit simpler to us because we have to take all the elements which are divisible by 10, right? So R2 is, in R2 we have to take all such elements whose sum is divisible by 12. Is divisible by 10, right? So since if I take 1, then if I want to make it some multiple of 10, then there should be 9 here. Then only it will become, the addition will become 10 and 10 is divisible by 10. Similarly, if I want 1 here, but again, we have to consider that this 9 should be an element of y. But we can easily check that 9 does not belongs to y. So that means 1, 9 won't be here. So that means this element won't belong. Again, so if I want 1 plus something which is divisible by 10 or any odd number plus something which is divisible by 10, is it possible? First thing we have to observe, right? So if a plus b is equals to 10 multiple of something k. Now here you have an even number, right? Here you have an odd number, right? And here you have some number which is divisible by 4. So that means b is some 4 multiple of something, right? So here you have even number. So is it possible one odd number and one even number add up and become an even number? So is it possible, right? It's can't. This is not possible, right? You are discussing summary. Yeah, I will discuss summary after these 2 questions. Okay. So that means we cannot make such type of combination, that we cannot add one even and one odd number to get an even number. So that means R2 is simply 5. Okay. So here we get R1 and we get R2. Now we have to answer the following question. First thing says that R1 is symmetric. So in R1 we observe that if 1 is here, then 1 can't be here, right? Because here we have to take all the multiple of 4, and multiple of 4 are always even. So that means we cannot find any pair like this, AB and BA. And AB, AB and BA type of. So if AB is there, then BA can't be there. Since B is some 4 multiple of something, and 4 multiple of something is always an even, right? So if AB is there, then BA can't be there. So that means R1 is not symmetric. So that means R1 is not set. Right? This is PYQ questions. Yeah, see in R2 what's happening here. So in R2, we have to find out all those element A comma B belongs to X cross Y in such a way that A plus B mod 10 is equals to 0, right? So what does it mean? So it means that A plus B is divisible by 10, right? Then what does it mean? So it means that A plus B is 10 multiple of something. Now here we know that A is an odd number, right? B is an even number. Since why it is an even number? Because B is a multiple of 4. Multiple of 4 means multiple of 2 also. And any integer which is a multiple of 2 is an even number. Here we again have an even number because again it's a multiple of 10 and 10 contains 2. So it's a multiple of 2. So that means here we have an even number. And you can observe that if you add odd plus even, you will again get an odd number. Why you will get again an odd number? Because even can be written. Suppose n is your even number. Suppose this is m and this is n. And n is even, right? So if n is even, then n minus 1 plus 1. You can do it, right? And here n minus 1 is an odd number, right? So that means this does not divisible by 2. This does not divisible by 2. And we have 1 here. So you can easily observe here that if you add one odd number and one even number, the result will be an odd. Just a basic observation, nothing more. Okay, got it. So that's why R2 is empty. Okay. Now we observe that R1 is not symmetric. Why it is not symmetric? Because if any element A comma B belongs to R1, then A is an odd integer, odd positive integer. And B is an multiple of 4. That means B is an even number. So if I want B comma A belongs to R1, then what I want B is a factor of A. But before that, I want B comma A is an element of X cross Y. So that means I want B belongs to X and A belongs to Y. Now you can easily check that X is a set of all odd positive integers. So that means B cannot belongs to X and A cannot belong to Y. So that means if AB is there, then B comma A can't be there. So that's why we say R1 is not symmetric. Is it clear now? Because A is an element of X, right? And X is what? X is the set of all positive, odd positive integers. Yeah, fine. Now let's move to another thing. So again, we have the transitivity property left. So is R1 transitive? So suppose that here from the before observation, what I observed that if A comma B is an element of X cross Y, then B comma A won't be an element of X cross, right? So for transitivity, what I want this hypothesis that A comma B and B comma C should be an element of should belongs to R. So that means this should be an element of X cross Y. This should be an element of X cross. But if A comma B is an element of X cross Y, what does it implies? So it implies that B belongs to Y. And here it implies that B should belongs to X also. But if B is in Y, this will implies B is a multiple of 4. So that means B is a multiple of 4, means B is an even number, right? And B belongs to X will implies B is an odd number. But this can't possible. So that means there does not exist any A comma B and B comma C belongs to R1. So trivially, vacuously, we can say R1 is transitive because we cannot find any pair which violate our property R1. So that's why R1 is transitive. Right. So we have 2 questions. After that, we will discuss summary. Not only, we will try to do a couple of questions also. But first, let me concentrate on main concept, which I have to clear. Okay, so you got that R1 is not transitive. Now, similarly, you can proceed with R2. Again, R2 is what? Again, R2 is all A comma B belongs to X cross Y in such a way that A plus B mod 10 is equals to 0. So that means A plus B should be divisible by 10. But we got that R2 is 5. So whenever the relation is an empty set, this is the relation. Whenever the relation is empty set, then it is trivially symmetric as well as transitive, because we can't find any pair which will contradict our properties, because we can't find any hypothesis condition. So that's why it's trivially symmetric as well as transitive. Is it clear? So R1 is transitive vacuously because we can't find any pair which violates our property. Similar case will happen with R2. R2 is again trivially symmetric and transitive, as we cannot find any of pair which contradict our hypothesis. Okay. Is this clear? So the question says this. This is the question. Okay, so let's quickly move to the next question. Where can I get previous year questions? Can someone share the links of previous year questions in the chat box? Okay, so now I have this question here. This question is based on the Venn diagram thing. So first, let me see. Transitive property says transitive. So what happened? So if hypothesis should be there. If there is no pair which satisfy our hypothesis, we cannot contradict our conclusion. So if hypothesis is there, so that means if you could find 2 pairs A comma B and B comma C in your relationship, then you have to check this property. Then A comma C should belongs to R. That means if you find 2 pairs of the form A comma B and B comma C in your relation, then A comma C, this pair should be in your relation. If the hypothesis is not true, then we can vacuously say that okay, my relation is satisfying that property. Okay, fine. So now let's solve this. Before solving this question, let me explain Venn diagram and sets, subsets, and all those things. So what does a set? So a set is a well-defined collection of objects. Right. So there are 2 ways of writing set. First is write the elements of sets A1, A2, and so on. And the second way is the descriptive type. That means A1 belongs to some other set with some certain properties, some certain relations. Not particular relations, some certain properties. Right. So these are the 2 ways to describe a set. And after that, we have some notion of subsets and cardinality of a set. and power set 10 out. Okay, so we say B is a subset of A if for all B belongs to B. This is a sign for belonging and element. If for all B in B implies B is an also element of A. So that means all elements of B are in A, then we say that B is a subset of A. The most natural way to say that two sets are equal, if and only if, this is the way to write if and only if and only if. By if and only means this way is also true and the conversely is also true. So we say that two sets is equal if and only if A is a subset of B and B is a subset of A. Right? Okay. Someone raise hand? No? See, now there's a what we call cardinality of set. So by cardinality, we just mean the number of elements in that set. This is a hash is denoted for a number of. If I want to write the face number of, I'll just write hash. Okay. This is just a mathematical language to write abbreviate things. Okay. Fine. Now we'll move to Venn diagram. So Venn diagram is actually a pictorial way to demonstrate our sets and intersection and union of. So let me define what is the union. So I'll say A union B. A union B is a set of all those element X such a way that X is in A or X is in B. Right? This is the union. The second thing is intersection. A intersection B is all the sets X in such a way that either X is in A. Sorry, not either. X is in A and X is in B. So when we use or, that means we are talking about union, and when we use and, we are talking about intersection. Okay. Yeah, pictorial representation of sets is a Venn diagram. So suppose you have three sets A, B, and C, and the Venn diagram of those sets can be demonstrated using such type of pictures. Okay, so this is your set B, sets, right? Here, this total circle represent the whole sets, and the intersection portion will represent the intersections, right? So here, the center one, the center part of Venn diagram will actually represent A intersection, B intersections, right? And this part will this part with this part. I mean, you can easily check which part represent which set, right? So I'm just saying this yellow part. This yellow part is actually representing. If you consider simply this yellow part, not this one, simple this yellow. Okay, so it's actually representing the all elements which are A intersection C, but not the elements of B, right? So in this way, you can interpret the Venn diagram common between these sets. Yeah. Okay. So now there is a formula for finding the we say the formula of inclusion exclusion to find the cardinality of union of all sets. We know that the cardinality of A union B is actually equals to the cardinality of A plus cardinality of B minus cardinality of B intersection B. This is one formula. Another formula is the cardinality of A union B union C is actually the cardinality of A plus the cardinality of B plus the cardinality of C minus the cardinality of A intersection B minus the cardinality of B intersection C minus the cardinality of C intersection A, and plus the cardinality of A intersection B intersection C. I'm not going to prove these two formulas, but I hope you can check on any of the video lecture. There you will find the proof of these two very useful formulas for finding the union and all other things. Okay. Okay. Now let's move towards this question. Yeah. So this is your question. I hope it's clearly visible. I'll give you 10 minutes because it's a bit calculative. So you can use the calculator and all. And it's a bit conceptual also. So just try to solve it. Observe which set, which cardinality we have to find and use Venn diagram to compute it. Okay, that's your hint. It's 8:47. So let's meet at 9. So Divya, yes, you want to say something? You can meet yourself.
Ma'am, can you just read out the numbers that you have written for this particular question?
The numbers?
Yeah, all the numbers.
Okay, yeah.
Thank
So this is let me. So there are 1,000 students and 570 for maths, 390 for physics, and 230 for chemistry, 90 for physics, maths and physics, 140 for physics and chemistry, 100 for chemistry and maths, and 100 which does not like any of the subjects. We have to find the number of, then this again, the sign is actually denoting the number. So we have to find the number of students who likes only one of the subjects. Okay. Union formula for 3 sets. Let me write it here. We have to find the number of students. The number of students who write only one of the subjects. Only one. Any one of the subject. You guys are understanding what I want to ask, right? Either maths, he likes either maths or physics or chemistry. Exactly one. Only one, except only one means exact. So A union B union C. It's simple. Just add all the sets. Add all the cardinality of single set. Subtract all the cardinality of two sets intersection. All possible two sets intersections. C intersection A B हो गया. B C and then C A and then add all the intersections, all the possible three sets intersection. It's called inclusion and exclusion formula. Yeah, it's a tough one. Yes, sir. Do you want to say something? Please unmute yourself.
Yes, ma'am. Ma'am, the total sum of the marks is 11190, and the total marks
No, I'm not understanding what you are asking. Actually, your voice is a little low.
Okay, ma'am, wait a minute, let me understand.
Adiba, you want to ask something?
Oh, yes. Ma'am, am I audible?
Yeah.
Ma'am, these two formulas that you just provided, then most of the questions asked like this can be solved from these two formulas, right? Or the other formulas that we have studied in our respective classes will be used too.
See, I don't know all about all the formulas, but yeah, these are the basic set theoretical formulas. So they will be used in many scenarios. So it's better to learn much formulas. I mean, any of the formulas. Some of you are getting correct answer, but there are so much variety of answer. So just recheck. I can't tell you now. Let's try once again. Swayam, you are not right. It's not the correct answer. I think it's not. Okay, so many of you got some answers. So let's solve it. So let's say cardinal M is the set of students who like maths. So the cardinality of M is 570. 570. The cardinality of P is 390. The cardinality of C, the P means the set of students who likes physics. Okay. Similarly, C means the set of students who likes chemistry. Okay. Cardinality of M intersection P is 90. Cardinality of P intersection C is 140, and the cardinality of C intersection M is 100. Right? And 100 students don't like any of the subject. And 100 don't like any. So in total, so if I want to represent the situation using Venn diagram, how I'll do? So in total, my universe is of 1,000 students. This is my universe and it's of 1,000 students. Here, some students likes maths. Some likes maths. Some likes physics. And some likes chemistry. Right? And we have to find number of students whose likes exactly one subject. Right. So from this line, that 100 students don't like any of the subjects. So that means 100 students are lying in this area outside these three circles. So from this line, we can imply that the cardinality of M intersection P intersection C is nothing but, sorry, not intersection, union. That because 100 students are outside of our circles, so that means the cardinality of union is nothing but 1000 minus 100, right? Because 100 student does not belong to any of this, so that's why the cardinality of union is 900. And we have to find the number of students which likes exactly one subject. So that means the number of students which present in the same, either they could like maths, or they could like chemistry, or they could like physics, right? So that means I have to find the number of students which lies in this black shaded area, right? Is this clear to everyone? What I want to find, right? I want to find the number of students which are sitting in this black shaded area. So for finding this black shaded area, I get some intuition. Okay, if I'll find the whole union and this portion, this intersection portion, this portion, and this portion. If I find the union and find the area which presented in this yellow region, and I subtract this yellow region from my union, then I'll get the required number which I want to find, right? So now what's our goal? Our goal is to find out the cardinality of this yellow shaded region. So how could you find this yellow shaded region, right? So this yellow shaded region, so the number of student lies in yellow region is equals to, so what we have to do, we have to consider the cardinality of maths intersection with chemistry, and we have to add up with the cardinality of chemistry intersection with physics. Again, if we add the cardinality of math intersection physics, then I can find the area of this region. But you can observe that we calculated this middle part thrice, right? We calculated this intersection, that M intersection P intersection C thrice, 3 times, right? So that means I have to subtract it 2 times so that I can calculate it exactly once, right? Because I calculated 3 times, because in this region also that the whole intersection is contained in this region, the whole intersection is also contained in this region, the whole intersection is also contained in this region. So that means if and I want to count that region, but exactly once. So that's why I have to subtract that region twice, right? So mass intersection, C intersection B. But the thing is, if I compute this area and subtract this area from my union, I'll get the required number, right? So for that, what I want the cardinality of all those sets. But here I don't have the cardinality of intersection. So for finding the cardinality of intersection, I'll try to use the cardinality of union. Okay. But we have the formula that the cardinality of M union P union C is nothing but the cardinality of M plus the cardinality of P plus the cardinality of C minus the cardinality of M intersection P minus P intersection C minus C intersection M, then plus M intersection P intersections, right? So using this formula, I can calculate what is the cardinality of M intersection P intersection C. What is it? Can somebody quickly answer? 490? 630? I have to calculate. 40? 50? 40. Okay. So let's assume it's 40. I mean, not let's assume. You guys calculated already. So it's 40. So that means the intersection is 40. So that means the number of students belongs to shaded area R is equals to, we have to add up these three intersections. That means we have to add 90 plus 140 plus 100. And then I have to subtract 2 times of 40. So that means I have to subtract 80. So answer is 250. So that means From the above discussion, we'll get the number of student lies in yellow region is equals to 250. So that means the number of student likes exactly one subject is nothing but the union, and the union is M union P union C minus this yellow shaded region. So that means 900 minus 250, which is nothing but 650. Right? So the answer is 650. Yeah, correct. So many of you got the correct answers. So very good. So why did we multiply it by 2? See, in this for counting the number of students lies in yellow region, we counted this area thrice, because this area is also part of M intersection C, C intersection P, and P intersection. So that means we are counting this area 3 times. That's why we have to. How can you use the formula? Because the formula will contain either the cardinality of M, P, or C. We have to find this region plus this region plus this region. That means the formula is not there. You have to use the intuition. Okay, if I find the number of student lies in the union and subtract this area, I'll get my region. The intersection is 40, then we are just multiplying. Let me explain once more. Yeah, calculation is correct. So see, here we have to find the number of students lies in black shaded area, right? We have to find the number of students which lies in this black shaded area. If I want to find the number of students lies in black shaded area, I just have to do that union. This is the total union, and then you have to subtract this part. Then only you will get the black shaded areas, right? So we can find out, we have already the union, because union is computed by the fact that 100 student does not like any of the subjects. So that means 1000 minus 100, that's why 900. That means we have 900 students present in this union. Now we have to find out the students which lies in this yellow part. So this yellow part, this wing is actually represent the cardinality of M intersections. This wing will represent the total, the whole wing, this type of. This wing will represent the cardinality of C intersection 2. And similarly, this wing will represent the cardinality of M intersection. So if you add these all intersections, you will counting this centered regions thrice, because this region is again a part of this wing, right? Part of this wing as well, and part of this wing as well. So that's why we have to subtract this. And after we will do, you can try another way if you want, but that's the most general way when anyone could solve this. Okay, so I'll unmute you guys one by one. So let's start with Suresh. Suresh, you want to say something, ask something?
Yeah, ma'am. That how did we calculate M intersection C intersection P? That's what I have.
doubt.
We just use the formula. We have all the values for substituting in this formula. We have cardinality of M, P, C, intersections, and union also. We just computed union, right? 1000 minus 100.
Yeah. Can you scroll down once, please?
Yes.
Then you mentioned two cardinality of M intersection C intersection P, right? So what will we substitute there?
No, don't use this formula. For union, for finding the intersection, you have to use this formula, the second one.
Okay.
Here you have all the values. You just don't know the union, so that's fine.
Understood, ma'am. Thank you.
You can unmute yourself. Hello,
ma'am.
Yes.
Yes, ma'am. Ma'am, we found maths intersection physics, intersection chemistry, that is the middle part of it is 40. So, and maths intersection physics is 90 minus 40, 50.
Okay, so you are computing in little different way, but that's also correct. You are just getting intuition from Venn diagram that if you subtract that area.
So, ma'am, the yellow colored part, according to the diagram, Venn diagram, is coming out to be 250.
Yeah, right.
And so, ma'am, the only maths or only physics or only chemistry will be 650, right?
Right. So 650 is on
Okay,
we computed.
the answer. Oh, got it, ma'am. Thank you. Sorry.
Now let's come to next person. Pranjal.
Yes, ma'am. Ma'am, I had a doubt like how did we get 40? I didn't quite get it.
You're not audible that clearly.
Hello, am I audible?
No, your voice is little bit low. I can't understand. You can message in chat box. I'm looking at there. So now Ujjwal.
Yes, ma'am.
What's your doubt?
Ma'am, I have a doubt in the question. Ma'am, the total of students number is 1000. Okay? And the number of students in mathematics is 570, and physics would be 390, and chemistry 230. When we add these numbers, the total would be 1190.
Yeah, but there is overlapping of students now. That's why. If there is no overlapping, then obviously this sum will be more than the number of students. But there are some students who like maths and physics both, so they only counted once. That's why.
Oh, okay, ma'am.
Okay, so you guys can lower your hands. Yes, sir. Do you want to say something?
Ma'am, I have a question in this. Like, you use, ma'am, two formulas. Can't we just use the one formula which you told, like the long one?
No, see, we cannot use that formula directly because what region we have to compute is not present in that form. Here you have to compute exactly once. So exactly once means not entirely cardinality of N, not entirely cardinality of C.
Once we will find the, like, ma'am, the intersection, like A intersection.
Sorry, your voice is too low. I can't understand you.
Ma'am, can you understand? Can you tell me why, ma'am? I'm not getting
You
it.
can message in chat box, please. Okay, so let's move forward. Without wasting your time. Long question I want to take is okay. So this is your question. So in week 1 and week 2, we have two topics. First, majorly two topics. First is the relation, Venn diagram, sets, subsets, cardinality of sets and all. And second thing is the equation of line, the equation of intersection of two lines, the point of intersection, the section formula and all those things. But those things are much more, what we can say, computational part. There you have particular formulas. They derive formulas in lectures. So I assume that you guys know the formulas. I'll just explain how the equation of line, what is the equation of line, what is the slope, and all those things. And after that, we can jump to some practice questions. Okay. This is the formula, and from there I'm finding the intersection and then subtracting it from the subject and then adding subject with some not. So you can do in this way also, but I don't think there is any error, but we have to check. Okay. If you try in this way, is your answer is correct 650, then it's okay. Function domain. Okay. Function domain we can cover. So we can cover. Yes, Guru Mahendra, you want to say something? No.
Oh, hi.
Yes.
I'm
Yeah.
still confused with this cardinality thing. So my main question is like when we are supposed to -2, and I have posted similar question in the chat as well. And in that question, the answer is 110. It's a part of a mock question. And in that question, we are subtracting it 3 times. So I'm sort of confused when we are supposed to use the exact formula and when we are supposed to -2 and when we are supposed
See,
to -3.
by intuition, you'll get some idea that if I right. So by intuition, you'll get at some idea that this intersection part is a part of this wing, as well as this wing, and as well as this wing, right? So here, I want this intersection part to be counted in my yellow region, right? That's why I take one part and subtract it from others. That's why I subtract, I do -2. If you don't want this region, then you will subtract it -3 times, right? So by using Venn diagram, take some intuition that you know how does area puzzle look like. You have to take that area, so that means you have to take exactly one zone. Am I audible? Hello? Forty will get just by using the formula. Okay, so let's move towards the domain of function, and after that I'll move towards the which week revision is going on, which is not distinct. Yeah, 1 and 2 both. I'm not discussing each and every topic. I'm just discussing the major revision portion. Okay. So now, what is the function? Okay. So function is actually a map. Map means what? Again, for defining function, we need 2 type of sets. So a map from A to B, or instead of map, let's say a relation. So relation from A to B is said to be a function. If for every A, after 40, what I did, you will look at here. So let's get back to the function. So function is what? So relation from A to B is said to be a function if for every A in A, there is a unique B in B in such a way that this function f will maps A to B. Now, in the definition of function, there are 2 important things you have to observe. First thing is every. So that means for every element of A, there should be an output. We can consider function as a machine which will take inputs and give you outputs. But it should take every input, I mean every member of A to be as an input and give a unique output, not several outputs, unique output. So in the definition of function, there's only 2 keywords. First thing is every, and the second one is unique. So if every element of A, you are getting unique output for B, then that relation is said to be a function, right? And here, the set A is said to be the domain of function. So that means all elements which can be taken as unique inputs of the function, right? Those elements are said to be domain. The set B is said to be codomain. And if you consider this set, that all elements of B in such a way that there is a A in A such that F maps A to B. So that means if you collect all those elements from B, which has pre-image, by pre-image, which has an input, then such type of, then this set is known to be the range of set. By unique, you mean singular. Yeah, singular means, yeah, unique, singular. Because unique is one-to-one function. No. Unique is not one-to-one function. By one-to-one, we means unique output, unique input, unique output. That's called one-to-one function. If we have an input, we can have two inputs which can correspond to single output. Z numbers, yeah, sure. I'll give you simple example, very simple example to understand. Okay, let's just answer my questions. Okay. So this is your A, this is your B, this is B, and this is 1. A contains 1, 2, 4, and B contains A, B, C, 1. Okay. Now F maps 1 to A, 2 to A. That's it. So is F define a function? Robin, why define a function? Kunal, why it defines a function? Just you have two keywords, every and unique. No, not about the same output. You can have same output for different inputs. There is no constraint. By unique means, yeah, that's now I understood. By unique means singular. Only one output. The same output can correspond to two different inputs. Okay. Yeah, correct. The domain is not mapped precisely. So that means this every word get violated. That's why this is not a function. Okay. Fine. Now let's consider another example. Suppose now 3 will get mapped to B and 4 will get mapped to B as well as C. Now is this a function? Now is this a function? No. Why? Who say yes? No, this is not a function, right? Why it is not a function? Because for a single output, for a single input, we are getting two different outputs, distinct outputs. That means the uniqueness is got violated. That's why it's not a function, right? Now let's consider this example. Then the same output. So is this a function? Yes, it is a function because it is satisfying both of the property. Every element of a domain get mapped to a unique output, right? Fine. So this is a function. Now the other properties of function will be discussed in next revision session because I think that's a part of week 3 and week 4. Okay. Now we have to go for equation of line. So I'll just briefly define equation of line. Right. So if you have one point, so a point xy, not xy, AB, and you have a slope. Slope is what? Slope means if we change x, how does y will change? At what rate does y change? So that means if you have 2 points, x1, y1, x2, y2. Then m denotes the slope of line. Slope of line passes through A and B. So it's simply y2 minus y1, that means change in y upon x2 minus x1, change in x. This is the slope of line passing through 2 points. And the equation of line is simply y is equals to mx plus c. Here c is the y-intercept. Okay. That's in week 5. I think. 1 on 2. Yeah, that's not a, I don't think that's a part of this discussion. Okay, so this is the equation of line, general equation of line, where I'm denoting the slope. Slope means if we change x, how does y will change? And what rate y will change? Right. So if we have 2 points, we can easily compute the slope using the formula. This is the general equation of line. And if you have 2 points, the equation of line, this is about 3 points. Equation of line is y is equals to the slope y2 minus y1 upon x2 minus x1, x minus x1, and plus y. This is the equation of line passing through the function. Is map dot in functions. Yeah, function is mentioned in week 1 because we need functions. But the precise definition of domain range, I don't think that's a part of our discussion. But although I stated the domain range both of times. So this is the equation of line. Now, if you have two lines, let's say y1 is equals to m1x, sorry, y is equals to m1x plus c1 and y is equals to m2x plus c, right? So there's a formula for finding the point of intersection, right? How does we find the point of intersection? We will just take x1 comma y1 to be a point of intersection, substitute the value here and solve the equations. That's it. Yeah, it is mentioned in week 1, but the only definition, domain, codomain range, I already stated, right? About 1 on 2, I'm not sure, but I'll state it, okay? Okay, so the point of intersection, you guys know the section formulas, right? If we have a line segment AB with some points x1, y1, x2, y2, and if some point C intersect this line segment in m ratio n, then you have the formula how to compute the cardinalities of these points. Okay. So yeah, correct elimination method we can use for finding the point of intersection. And similarly, there's a formula for finding the coordinate of point C if the line segment is got sectioned internally using m ratios. I don't remember exact formula. It's something m plus n is there. This is m explain something like this. Okay. See, for finding point of intersection, you have two equation of line, right? So let's suppose this is your point of intersection P. Now substitute the value of P in these two equations and eliminate the M1 and C1. M1, M2, C1, C2, and you'll get the answer. Okay. Fine. So let's do a couple of questions. You guys want to solve some questions or you want to discuss more theory? Because I think I discussed major of the theory part. There's only this formula part is left. So you can go through the theory questions, right? So we have half an hour, more than half an hour. So let's solve some good questions. They can come. I don't know. Yeah. So here the answer is already given, but let's forget about this question. Okay, let's solve this question. Okay, it's a good question. This second one. This one. I'll give you 10 minutes to solve it. Sit back, relax, and solve it. Yeah, it is compulsory to solve it, but I think you will got failed if you score less than 50. You can apply for requalifier also. There's one option. It depends on your preparation, how you will prepare. The question will be tough or easy according to that. Okay. Okay, so just solve this question and answer in the chat box. You can no, you can just still tell the number. Percentage is not prepared. This question I think is based on Venn diagram. Hello, I'm audible. Am I audible? Hello, hello. Who's this 650 at home? Okay, let's start. No, I think this is the only. Find the number of people who like at least two of the events. General, that's the second part. That's the third part. And the second part is find the number of people who likes only of the three journals. So let's try to solve first. So they say we have to find out how many people like all the three movies. Okay. So that means if I consider, so in a survey, 500 people are there. So total number of people is 500. Okay. Now 49% like to watch comedy movies. Okay. So that means 49% for comedy movies. So let's say cardinality of C is 14. C is denote the number of percent people like the comedy movies. Okay. 53 likes thriller movies. So cardinality of T is 53. And 62 likes romantic movies. So let's say cardinality of R to be 62. And also 27 like to watch both comedy and thriller. Cardinality of C intersection T is 27. 29% like to watch both thriller and romantic. So T intersection R is 29. Now 28% like to watch both comedy and romantic. So cardinality of C intersection R is 28. And 5% like none of the above. So that means 5% does not like anything. Not to likes anything. So that means 95% will like everything. At least one, right? 95% likes at least one. So that means the cardinality of C intersection T intersection R is 91 in terms of percentage. I'm not calculating it in terms of number of people. We can do it at the end, or you can first convert this percentage into the number of people and then proceed. Both ways are correct. So I'm just trying to leave percentage as it is, and at the end, I'll compute the number of people just by the solving percentage. Yes, Kunal? You take intersection because they say end here, right? They like comedy and thriller. Whenever we have end in our phrase, we'll take it to be an intersection. Whenever we have or in our phrases, we'll take it to be union. We need to find all of three. So that means we need to find. Oh, sorry. This is not intersection. Union. It's a type of. 5% do not like anything, so that means 95% will like at least one of them. And whenever we have such at least one of them kind of thing, we'll use union. Right? So now we have to find out how many people like all the three movies. So that means we have to find out people who like comedy as well as thriller as well as romance. That means we have to find out the cardinality of C intersection T intersection R. Right? What we'll do, we'll just use our formula. So by formula, I'm computing it directly. So you can write the formula. Try to try to solve the calculation. I'm just trying to do. So it's 49. And, 3 27, 29, 28, So the answer is for this intersection, C intersection, T intersection, R is 15% of people will like all of the three movies. So if you count the number, then it's 15 multiplied by 500 upon 100, right? So that means the answer is 45, 75. Right? So got it? Is there any doubt? We'll just apply the formula and do the calculation. We'll come to the 15% or 75. Okay. So is this question clear to everyone? Revised question. See what happened? We just defined some sets according to our question. Here I am not converting percentage into people. You can do both ways. You can convert percentage into people first, and after that you can apply the formula. The basic formula for inclusion exclusion. This formula. That C union P union R is equals to add all things first, add one terms first, then subtract one intersections. I mean two sets intersections, and then add even intersections. Now here all other quantities are known, right? And this quantity is unknown. So we have to find out this. So just take all these into your left hand side and you will get 15 answers. So yeah. Here I am working with the percentage. That's why I got 15 using just by the formula. Just by the formula, nothing else. Just do the computation, you'll find it. The answer is 75. Okay. Shall we move forward? Or you want to spend more time on this question? Is there any doubt still? Okay. This is all but a theoretic question. Second and third sub question also. Okay. So I'll give you the little bit intuition here. So in the second question, they say that find the number of people who likes only one of the three genres. Only one we have to find out. So again, that means we have to find out that that region. So if this is your Venn diagram, only one means either this one, or this one. So again, you have to go by that subtraction method. Find the union and then subtract the yellow region and find the answer. That will be your only one number. And in the third subpart, they say find the number of people who like at least two of the given zone. At least two means either this intersection. That means in the third region, you have to find out. In the third question, you have to find out at least two. That means it could be three, but at least two there should be. So that means you have to just find out this region. I mean, you just have to do union minus intersection. That will be your answer. No. Wait. I explain it wrong. For at least three, you have to do something else. This way. See, you have to find out the number of people who like at least two of the given zone. Okay, so if this is your Venn diagram, then you have to find out people with at least two. So if people belong to this region, if this is CTR, so if people belong to this region, then they will like R and C. If they belong to this region, they will like R and D. If they belong to this region, they will like C and D. So that means here we are satisfying this condition, at least 2. But if you also consider the intersection region, here the people like 3 movies. So that means here also people settings which like at least 2. So that means you have to find out the people who are lying in this this Venn diagram, this region. That's the answer for third one. Fine. Let's try to solve this third one. SSC. SSC. This is one SSC based question. So but calculators. Yeah, although SSC is not part of week 1 and 2. Thank you. And you solve that to like at least one. Yeah, for at least one, you have to just calculate this region. That means for calculating this region, you have to find out this expression that all the 2 terms intersections, that means C intersection T plus T intersection R plus R intersection C. And then since we are counting this intersection region thrice, we have to subtract it twice because we want it exactly. So 2 times C intersection T intersection. That will be your answer. For at least 3 conditions. You're getting 270. So it's so it says 77, 79, 28, and then minus 55. Yeah, 270 is the correct answer for third question. There will be a session day after tomorrow. Tomorrow I don't know, but day after tomorrow. So, this question has answered 270. Okay, so let's solve this question. It's a bit easy question. Based on this information, answer the answer question. Just match the following type of thing. Right? So now just explain what do we mean by antisymmetricity. No. In only one subject, we have to subtract at least 2 from the union. At least 2 will have different formula. For only one subject, we have to subtract the number which we will get from at least 2 situation from the union situation. Then only we can find out the answer. So here, anti-symmetric. So relation is said to be antisymmetric if AB and BA belongs to R. This is your hypothesis for antisymmetricity. You will imply A is equals to. So that means A is related to B and B is related to A. Then A is equals to. Okay, so just tell which type of relation this one is. Just match it over here. Let's say this is 1, 2, 3, 4, 5. Yeah, 5, 6. I already given. And let's say this is A, B, C, D, E. Okay, match the columns accordingly. Symmetric. Yeah, symmetric and antisymmetric have all are symmetric. Then we have to go for sub question. Okay, so this is the four subpart. Just answer accordingly. But how could you see all the things? Now the question is totally visible, right? Just answer these four subparts. Do that. So symmetric. So in symmetric, we have hypothesis that if AB belongs to R, sure, and the conclusion is then BA should belongs to R. This is called symmetry. R means relationship. Okay. Now antisymmetric says that if AB and BA belongs to R, will imply A is equals to B. That means if there is two pairs AB and BA which are in your relationship, then it will imply A is equals to B. Okay. Now you have to state true or false. R6 does not match with any of the definition. False. Okay, so let's discuss this question. So here, first option says that R6 does not match with any type of relations given in column B. So in column B, we have symmetric, antisymmetric, identity, transitivity, reflexive, and equivalence. So equivalence relation means it's a combination of reflexive plus symmetric and plus transitivity. That's the relation is called equivalence. Okay. And by identity relation means it maps to every element to every element. That A comma A. This type of relations are identity. But here Audible? No. So the identity relation is this type of relation that every element should map to every other element for all element. So now R1 is given to this only 1 comma, right? So that means R1 is symmetric relation, obviously, because it satisfies the vacuous condition that A comma B is in R1. So since 1 comma 1 is only in R1, so that means B comma A, which is again 1 comma, if this is 1 comma 1, then B comma is again 1 comma. So it's also an element of R1. So it means R1 is a symmetric relation. So this option is false because it corresponds to symmetric relation. Okay. The second option says R1 matches with all type of relations except antisymmetric relation given in the column B. That option is also false because for antisymmetricity we want some hypothesis, right? For antisymmetricity, we want the hypothesis of A comma B and B comma A belongs to 1. Then this will imply A is equal to 1. So here only one element is there, 1 comma 1 and 1 comma 1. And 1 is equal to 2. So it's antisymmetric, trivially antisymmetric. So that means this option is also not true. Because R1 matches with all type of relation except antisymmetric. But R1 is antisymmetric. So now the question is, in total, how many relations given in column A matches with transitive relation? So because it matches to, they say it does not match with any type of relation, but R1 is symmetric. So that's why this option is false, right? R6. Oh, sorry. R6, they say. I'm so sorry. And this. So let's check the first option again because I computed for R6. So R6 is 1 comma 1, 1 comma 2, and 2 comma 1, and 2 comma 3. Okay, so this is our R6. Now the first option says that R6 does not match with any type of relation. So here we have first thing symmetricity. So since you know that 2 comma 3 is an element of R6, but 3 comma 2 does not belongs to R6. So that's why it's not symmetric. Now antisymmetricity. So again 1 comma 2 and 2 comma 1 are the elements of R6, but 2 is not equals to 1. So again it's not antisymmetric. Obviously it is not identity since 2 comma 2 and 3 comma 3 is not an element of R6. So again not identity. For transitivity, again it's not transitive because 1 comma 2 and 2 comma 3 is there, but 1 comma 3 is not there. So that's why it's again not transitive. And again not reflexive because again 2 comma 2 and 3 comma 3 are not the element of R6. So it's obviously not an equivalence relation. So that's why first option is correct. I'm so sorry I got confused. So 1 is true. Yeah, 1 is true. And the second one is false, right? Because R1 is antisymmetric since it is vacuously antisymmetric because there is no two pairs to compare. We want AB and BA both. Now go to option number 3. So option number 3 says that in total, how many relations given in column A matches with transitive relation? Okay. So R1 is transitive, vacuously transitive. What about R2? So R2 is again vacuously transitive because there is no two pairs A, B and B, C type of thing. If we want to say it is transitive, we need some pairs. Yes, Divya, you want to say something?
Ma'am, I have a doubt in that first option. R6 does not match with any type of relations given in column B. Just check if I'm correct, my understanding. What I feel or I thought that R6 satisfies transitive relation. Why? Because this is my explanation. Just let me know if I'm wrong.
Oh, R6 is transitive. No, R6 is not transitive because
Yeah, that is one comma one is there, A comma B. So then 1, 2 is there, that is B comma A, and then A comma B, that is 1 is there.
right. But we have one pair this, right? That 1 comma 2 is there and 2 comma 3 is there. But 1 comma 3 is not there.
Yeah, but this is not there. But then I think in the previous sessions, what I understood was even if it is not there, since 1, 2 is there, it is transitive.
No. For all pairs, we have to check our conditions for all pairs. If you find such pairs, any number of pairs. Here we got 2 pairs, but there could be any number of pairs. So we have to check for every pair.
So you have to say
It should
you have
satisfy.
to check for every element that is there in set A.
Right.
Every element should satisfy the transitive relation. Only then we can say that relation is transitive.
Yeah, correct.
Okay. Okay. Thank
you. So this is one thing. What we have? R2 is transitive again by vacuous choices. Now what about R3? How many? Okay. So R3, we have 1, 1 and 1, 2. So again, we have 1, 2 there. So that's again R3 is transitive. Now about R4, again R4 is vacuously transitive. See, for transitivity, there is no two pairs to consider, A comma B, B comma C, right? So that means hypothesis is already, there is no two pairs using which we can contradict our statement of transitivity. If you find two pairs AB and BC such a way that AC is not there, then that will imply that it's not transitive. Here, we cannot find any two pairs which will contradict our hypothesis. That's why it's transitive. We can use its full option. Okay, so symmetricity simply says that if symmetric means what? Symmetric means if A comma B is there, and then B comma A should be there, right? And anti-symmetric means that if A comma B and B comma C is there in R, then only A comma C should be there in R. Okay. So let's go through options one again. So first option says that R6 does not match any of the relations. R6. Okay. So for R6, we have for symmetricity, we have that 2, 3 is there in R6, but 3, 2 is not there in R6, right? So this will imply not symmetry. Okay. Now for antisymmetricity, we have 1, 2 and 2, 1 is there in R6, but 2 is not equals to, right? That means A is not equals to B condition. So that's why it's a not antisymmetric. Okay. Now for identity relation, for again that 2, 2 is not there in R6. So that's why not identity. Or we have 1, 2 type of pair also there. So 1, 2 is also there. So that means not identity. In identity, we want all A, A type of pairs. So okay. Now transitivity. So again, this 1, 2 and 2, 3 is there, but 1, 3 is not there in R6. So that's why not transitive. See, transitivity, in transitivity, we have this type of B, C will imply A, C is an. This is in transitivity. Okay. In antisymmetricity, we have this kind of thing. AB and B will imply A is equals to. There's a significant difference between them. Okay. Yeah, like no EVC and no VC, then there is no AC. Yeah, it's vacuously transitive, we can say. No, see, this type of pair need not always exist, AB and B. If you have both of them, then only A is equals to C. That's why it cannot be totally identical. Okay. So I think you guys can do this question now. Okay, let's do this question in full detail so that no one will get confused. So this is my question. Here I'll get some of the things for R6. That R6 is neither, it's not satisfying any condition. That's why option 1 is true. Okay. B, C. Now let's move to second option. Okay. So second option says that R1 matches with all type of relation except antisymmetric relation given in column B. Okay. So what is your R1? So R1 is basically R1 is this 1, 1, right? And what does antisymmetricity say? So antisymmetric says that if A, B and B, A is there in R1, then it should imply A is equals to 1, right? But here only 1, 1 is the element. So that means 1, 1 is there, 1, 1 is there, and 1 is equals to. So that means this condition is trivially true. So that's why R1 is antisymmetric. And that's why this option is not correct. Second one. Okay. Now let's go to third option. So what this third one says that in total, how many relation given in column A matches with the transitive? So we get that R1. So that means there is no pair to compare AB and BC. We want such type of pair to compare transitivity. So that means R1 is trivially transitive. Now R2, again R2 we don't have such pair. So that means R2 is also trivially transitive. Now R3, again R3, we don't have such pair. I mean, we have such pair that we have 1 comma 1 and 1 comma 2. But again, 1 comma 2 is an element of 1. So that's why R3 is again transitive. Now in R4 also we don't have such pair. So that's why R4 is again transitive. And in R5, let's see R5. So in R5, 1 2 is there and 2 2 is there. But again 1 2 is there. So yeah, we don't have any such pair. We have this thing that 1 1 and 1 2 is there. But this is implying that 1 2 is there. So this is correct. And again we have 2 and 1 2. Right? 1 2 and 2 2 is there. But again 1 2 is there. So that's why R5 is also transitive. But R6 is not transitive. We just saw that what is 6? 2 comma 1 comma 2 is there and 2 comma 3 is there. But 1 comma 3 is not there in R6. So that's why the option for the answer for fifth one is 5. Okay. The last one says in total how many relation given column A matches with reflexive relation. Okay, reflexive. So what does reflexive says? Okay, so reflexive means for all A in A comma A should be there in R, right? Okay, so first one is not reflexive because 2 comma 2 and 3 comma 3 is not there, right? The second, that means R1, R2. Okay, R2 is reflexive. What about R3? R3 is not reflexive, but because again 2 comma 2 is not there. R4 is again not reflexive. R5 is reflexive because our A is only 1 to 3. 1 to 3. Right? And R6 is again not reflexive. So that means R2 and R5 is reflexive. So answer is 2. Yes, R5 is reflexive. You can consider R5 as an relation which is reflexive but not identity. Because identity relation will contain only. R1 is not reflexive because 2 comma 2 and 3 comma 3 is not there. R1 is not reflexive because 2 comma 2 and 3 comma 3 is not there. Right? Reflexive means that for all A in A, A comma A should be there in R. That means for all element of A, they should be related to itself. That's the meaning of reflexive. Yes, Haridas, you can raise your hand. Yes, Haridas, you want to say something?
Ma'am, if A comma B belongs to some relation, but B comma C doesn't belong, is it still transitive?
It will be still transitive because we don't have pairs to contradict our definition.
Yeah,
That's
but in the first question you asked in this program, you took R2 as non-transitive
R2.
at the start of this lecture.
No. I think by mistake I take R2 not transitive, but R2 is transitive.
Okay, thank you.
Okay, so with this, I'll share this PDF with you guys, so you guys can look at these questions. In this PDF, there are many questions related to all other weeks also. So I'll share this PDF in chat box. You can try to solve it by yourself. Okay. So I shared the PDF here. Please have a look at this and try to solve the remaining questions. There are 15 questions related to every other week also. Okay. Fine. So, you guys have any other doubts? Let me unmute first.
Yes,
Piyush?
yes, ma'am. I doubt regarding the whole maths. I have cleared my all the concepts, but when I am trying to solve the question, I have some difficulties to face solving the questions.
Same problem, ma'am.
I mean, the concepts are clear, but you are not able to get how to solve the question, right?
Yes,
Yeah,
ma'am.
ma'am.
Just a slight of the answer, a slight of the working will make us write the whole question properly, whole answer properly. But that X factor is missing in every question.
Sorry, what? Hello?
Yes, ma'am. When I am trying to solve the activity questions that are given in the dashboard, then those questions are solving very easily. But when I am trying to solve the graded assignment
Okay, yeah.
solution or
Graded assignment are a bit tough, but we gave it a bit tough because you have so many resources, right? You have internet, you have chat GPT and all things. So you can use those to solve it. So that's why we
yes, ma'am.
want you to
Yes.
first
Ma'am,
get
what is the level of qualifier?
Sorry?
My question was that not that my question is that when I am solve the qualifier, then the difficulty is same for like graded assignment or decrease.
What can I say about this? See, in exam, there will be some questions which will map to graded assignment difficulties, but there will be some questions which are easy. I mean, it's a combination. Exam is a combination of all tough and easy questions. So we won't ask anything out of syllabus. So yeah.
The PDF only one and week 1 and 2 only, right?
Sorry, what?
The PDF is week 1 and 2, or because it's having only week 1 and 2.
It revision of 1 and 2, but the PDF contain much more questions, I think.
I can see only 1 and 2 week syllabus only, not 2 and 3. Sorry, 3 and 4.
In the PDF?
Yes, are you sure only one PDF, right?
Only one PDF. So I
But
think
I
it
can see.
contains only week 1 and 2 two questions only. But there is some SSC question.
Yes.
SSC is not in week 1 or 2, guys.
SSC week 2.
SSC is a part of week 2. Okay, so then it's only week 2, week 1 and 2. SSC is a part of week 2 because it's based on line equations.
Yes.
So, ma'am, please give me some tips to solve the questions and.
Your voice is too low. I can't hear it.
So, ma'am, please give me some tips regarding the solving questions.
Sorry, what?
Hello.
Speak a little bit.
Just practice.
For practice, you want questions. There are plenty of questions. You have activity, practice, this one, previous year questions.
He's asking for tips to clear exam. That's why I said practice well.
Acha. Tip to clear exam is study as much as you can.
Ma'am, I want a suggestion regarding the word problems that we get in week 2.
Please speak a bit louder. I can't hear you.
Okay, I need a suggestion regarding the word problems that we get for week 2 and all. How to how to arrive at the equation or what they're asking. Can you just explain like how to break that question and get what they want, so that after that we'll be able to solve with the formulas that we know and everything. Like how to attack a
Everywhere
particular
get stuck.
question.
Everywhere
That is
get stuck in the equation only.
See,
the
just
mainly the word
assume some
problems.
variable and then put the relations on that variable. That's the only thing. I mean,
Yes,
there is some
yes.
unknown quantity, right? So assume that quantity to
Yes.
be x, and then put all the conditions which involve that particular quantity. That's the only way to solve such equations problem. Assume whatever unknown quantity is there to be x, and then put the conditions there that they say twice multiple of this is this. So it means 2x plus this is this. So something like this. Just take first consider your particular thing, that whatever the number of age or person age is there, or some weight is there, some whatever the numerical quantity is there, uh, take that quantity to be x, and then try to apply all the relations on that unknown variable x. Then only you will find out the relations. And because first step is to find out the correct relation, right? Then only you can apply the formulas whichever you know, and you can solve.
Yes.
Exactly. Okay.
It will require little bit practice, I think, but when once you get a clear intuition what you have to do with that x, then I think it's easy.
Okay.
Is there any higher weightage for any of the week? Like,
Sorry, what?
hello. Is there any weightage for the weeks? Like, the week 3 got higher weightage or week 4 got higher
So the
weightage?
weightage, I think sir will discuss in next revision session. I think because he knows the weightage, that's why. I don't have
Hello.
that clear idea about weightage.
Hello, ma'am. I have a doubt.
It should be equal weightage, right?
It should be equal weightage, but
When
because there is
will be
only
the
4
next
weeks.
session held?
But I hear from others that only weeks 3 and 4 will be given importance. In other sections,
hello,
they
ma'am.
normally emphasize on week 3rd and 4th because of the complexity being higher on the side compared to week 1 and 2, which are
Week 3 and 4 are a bit complex, but
Hello, ma'am. I have a doubt.
in what way?
I am unable to create a polynomial graph like direct. I am confused in creating the direction of their
So you
behavior.
can ask these doubt to the sir. I mean, he will explain. From week 3 and 4, whatever doubts you have, just collect it and ask to sir. They will answer.
When he is coming?
I think on this Thursday, maybe you have a next revision session.
Tomorrow, I think. Thursday means.
Thursday is tomorrow, so I think tomorrow is.
Okay, we are waiting for it.
Tomorrow
Yes.
you have a session.
Okay.
Friday morning.
Friday, I don't think there's a session.
Because we are missing him
How
past
can
2
I
weeks.
get link? I don't get
Ma'am,
direct
I
link.
have a small doubt.
Okay, guys, I think we are done with this session.
Hello, ma'am.
Uh,
I don't get a direct link. I get from someone other's group.
You don't get the direct what?
Direct link of the sessions.
Why? There is a calendar. There
Ma'am,
you can find the.
I think my calendar not work properly.
Okay, good.
So you mail to
Check
support.
your Google Calendar.
I messaged, but they didn't get any solution of that.
Achha, okay. So just share your email ID. I'll check once if I can do something in
I
chat
have
box.
this
Yes.
thing today. Today there is an update about the examination centers that's been out. So the exams normally will be held in the morning, or both the sessions will be there.
You got any admit card?
No, they say the hall ticket will come 3 days before, but the exam center is out today. They have sent the exam updated the examination centers.
Morning. Just give me
Ma'am,
a
where
second.
did I share the link?
No, just share your email ID to me so that I can check your profile, that your calendar is working.
Where I share?
In the chat box.
Okay, ma'am.
Hello, ma'am.
Yes.
Ma'am, where did you share the problem PDF?
In the chat box itself. You can
Ma'am,
scroll.
ma'am,
You'll
please
find a clip.
send it again because I'm
After
not
that, so
able to
many
get it.
messages have come. Is there on the top?
No, actually, in between, I just got disconnected. So, could you, ma'am, please share it again?
Yeah, sure.
Ma'am, I shared the link.
Okay, guys, if you
Sorry, I shared the ma'am email. Please check.
where's your email ID? This RPL.
Yes, ma'am. Yes.
Let me share the PDF first. Okay, guys, you can leave now. Thank you for joining. All the best for your exam.
Ma'am, please do something for my calendar, ma'am.
Sorry, what?
For my calendar and update of session,
So
please do
the
something.
exam will held in morning as well as in evening. It depends on the student. We have two phases for that. So if you got selected for morning session, then we'll have exam at morning. The PDF is coming. I mean, it's loading very slowly.
Thank you.
Yeah, it's done.
Yes, got it, ma'am. Thank you.
Yes. Okay, thank you for joining. You guys can leave now. Okay? Good night.
Good night.
Thank you, ma'am.
Thank you.
Hello, ma'am. Is there someone? Can someone take me out?